Pause the video to see if you can solve this expression. Is the integral of x raised to dx, and then you subtract a 1 from it, and then you integrate it. There's no dx really over here. Hopefully you got some traction into this. This looks like a meaningless problem. Usually our integrations are of the type integral of a function of x dx, and this dx is of course the base of the rectangle, and this is your function. In this case we don't really have a dx, so this looks like a meaningless integral, but actually let's multiply by dx and divide by dx in the numerator and the denominator. And now let's first identify what this expression will turn out to be. So we've written down x power dx minus 1 divided by dx, and let's write it down in limits terminology. So we write this as x to the h minus 1 divided by h, and then we take the limit of h approaching 0. So we write down limit h approaching 0. And now this might be a familiar limit if you've already done limits. This is equal to log of x to the base e. But let's actually try to understand what this limit is. Now, to understand why this limit is equal to log of x, let's use the L'Hopital's rule. If we substitute h is equal to 0 in the numerator, we get x to the 0, which is 1, and then we subtract a 1, so we get a 1 minus 1, which is a 0 in the numerator, and we get a 0 in the denominator, so we are left with a 0 with 0 divided by 0 in determinate form. And so we can apply the L'Hopital's rule. All we're going to do is differentiate with respect to h, not x. We're going to differentiate with respect to h because that is the quantity here to which the limit is asked. So we differentiate x to the h to get log of x times x power h. And then you differentiate 1 to get 0, and then you divide by h. And then you divide by the derivative of h with respect to h, which is 1. And so now when we substitute h approaching 0 in this new limit, we get log of x multiplied by x power 0, which is 1, divided by 1. So we actually arrive at log of x. So here we are actually integrating. This whole section has become log of x. And so now we arrive at this familiar form where your f of x will actually be written as log of x. And now here's the second challenge for you. Use the integration by parts method to see if you can evaluate the integral of log of x dx. You can use the LIATE method, which is a very popular method. You've got log of x here, so you use log of x to be equal to u, and then of course dx will be equal to dv, and then you can use u v minus integral of v du is equal to log of x times x minus x divided by x dx. I'm doing it very fast here, but take your time and convince yourself this is the answer. And so it is equal to x log x minus x plus a constant. And so to summarize this problem, we multiplied and divided by dx in the numerator and the denominator. And this section, we evaluated it using L'Hopital's rule to be log of x. So we write down the integral of log of x dx, and now this is easy to evaluate using integration by parts to get x log x minus x plus a constant to be our answer. And now here are your challenge problems. The first problem is e to the I dx. There's no dx here, but I know you can manipulate this expression somehow to get a dx in here in the numerator. And of course, I is equal to the square root of -1. And then the second easier one is x plus dx to the n minus x to the n. And you integrate this. Good luck. Don't forget to like and subscribe to this channel. Talk to you again very soon.